Hey everybody, welcome back. So some supplies showed up and I think I've got enough here to start building an adapter to try and pull a couple of bull gears. I'll show you what showed up. We've got this. That's the large 1 7/8 by 12 nut, and then we have this. That's the 1 1/4 by 7 coupling nut, and I also ordered, this is a 5-pack of just 1 1/4 by 7 standard nuts. They look like they could maybe come in handy for something someday, so you know, that's options on the table. But these two pieces here and here are what I'm primarily going to be using, at least on the first attempt here, to try to make an adapter to get the hollow ram onto the end of the sprocket shaft. So this nut will go on the end of the shaft and we'll run it down until we get full engagement on those threads. There we go. Full thread engagement on the end of that shaft, and you can see I've still got about 5/8 of an inch worth of threads that stand out beyond the end of it. So my plan is to take this 1 1/4 coupling nut and join it to the end of this 1 7/8 by 12 nut, and that's going to be my adapter to attach this forcing screw to the end of that sprocket shaft, try and pull it. And I've been thinking probably the strongest way that I know how to make it is to turn the end of this coupling nut down and thread it to the 1 7/8 by 12 thread pitch that's inside that nut, so I can actually thread that into the large nut, you know, about 5/8 of an inch or so, and then we'll run some pretty heavy bead around the base of both of those, and I should have a pretty stout adapter for pulling. So I'm going to take this out. I think I'm going to use a South Bend lathe for this. So what I'm going to do is turn the hex portion down to round, at least to the base of this second notch right here. 5/8 is going to be just about between those two, so I'll give myself a little bit extra room for when I start threading. And well, we just need to get busy and see what we can make, right? I love the ticking of that flat belt. All right, so we're just cleaned up to my desired major thread diameter. You can see it was just about enough to take the flats out. You can just see just a few witnesses of where they used to be. That's just fine. Not going to cause a problem at all. So next step now, we set up for cutting the actual threads. All right, I'll see if I can walk you through the sequence here one time. You can see we've established some threads already, and we've taken our pitch gauge and we've made sure that we are on 12 threads per inch, so all is well and good right there. The cutter we have in here is for cutting threads. It has the right angle and nice sharp point on there. It's been giving me a few problems though, because this is a grade 8 nut and I've been having to use some oil. I started out dry and it just wiped the edge right off. I've already had to sharpen it a couple times, but with oil it seems to be doing better. So to set this up to cut threads, you have this chart on the front right here. So you look at threads per inch. I think you can see that. And we have down this column, there's our 12. So what you do, you take this lever and you just line it beneath the column that has the 12. Come over here, it tells you sliding gear should be in. That's this right here. It's like a plunger. We have that to the in position. top lever for our 12 says to the right. Here's our top lever, canted to the right. That's where we need to be. I also engaged the back gear. That's basically like a low range. So you pull this little spring-loaded pin, pop it down, and then this lever over here, that rotates that shaft and gear set in here, in or out. There, see? Back gear is in. So when this top pulley spins, the output is going to be a lot slower. So now, to cut the threads, what I always do is set the cross slide to 0. You can see our 0 mark is right in line, maybe a little hard on the GoPro, but cross slide always gets set to 0. We only ever advance the cutting bit deeper with the compound rest right here. That ensures, oh, and also the compound rest has to be set at 29.5 degrees to the center line. That ensures that as you feed it, you're only cutting fresh metal with this front side of the cutter, and this back slope just kind of keeps following the cut that you've already made. That's how you basically maintain proper thread pitch all the way across. We have this little feed dial right here, so we'll just start it up. I've chosen to use the 0 mark right there on the feed dial to engage every time. That keeps you basically from cutting a double thread or cross threading, what have you. That basically all these setups that we just went through times the auto feed to the rotation of the spindle to give you your 12 threads per inch. And resetting back at the 0 mark every time ensures you're on the same axis every time. That's the very simple part of it. So we're just about at 0. Pull up on the lever. There we are. We're engaged. Watch it come in. We're ready on the lever to disable the auto feed once we get to the end. There. We take the cross slide. We back it off. Go back for our return pass. We'll reset to 0 right here. Okay. We'll advance the compound rest. A few more thousandths for the next cut. And we're ready to go again. We get this close. We wait for that 0 mark to come back around. We'll re-engage at 0, monitor it in, disengage when it gets there, back out the cross slide, make a return pass, reset, again and again and again. Hopefully that makes sense. Okay, I think we're going to call that good because we're starting to get just tight enough. I'm going to need a wrench to go much further, and I'm okay with a bit of an interference fit. I just didn't want it to be too loose on there, so yeah, pretty happy with that. I think we're going to call it good. So outside now you can see I've got the whole setup on the end of the sprocket shaft. So what I did was took the 1 7/8 nut, ran it all the way down until I was out of threads. Then I took the 1 1/4 by 7 coupling, ran that down into the 1 7/8 nut until it too hit the end of the sprocket shaft, and then I cinched it all together. So what that does, it kind of preloads the threads in our pulling position. So we're going to run a bead of weld around here, join these two, make them permanent, but I wanted to cinch it and kind of preload everything so that when we put tension on this thing, it's not like the weld is going to have to give slightly first before the threads go and then finally cinch to the pulling state. It just kind of preloads everything and gets everything all on the same page. So we'll make it permanent. So here we are. Both pieces are welded together, threaded into one another. The way it's going to work, of course, we go on the end of the sprocket shaft like that. We'll run it down until we're all the way against that shoulder. Now we can join the gigantic forcing screw from that 30-ton puller set to the end of there, and I have enough room. I can engage all of these threads all the way down into there, which I will also do. Hollow ram grips onto this threaded part of the forcing screw, and I've decided to adapt in the old D3400 cylinder liner, same one that I used when I pulled that bevel gear out of that back end. So plenty stout. This thing is so heavy duty, so strong, I really doubt I'm going to exceed its capabilities. So that's going to be my push sleeve, pushing on the bearing. Of course, hollow ram will be exerting outward tension on this forcing screw, trying to pull the shaft, separate all that stuff, and hopefully it's going to work. I don't know, we're going to try and do this safe, but let's try it. So here's the setup. Just follow the hydraulic line, right? We're outside on the apron. Safety nut is just backed off of the gear, just far enough for that thing to move. And we have heavy, I put the 3-bar puller support down here because that's a good heavy push block for the base of the cylinder. Got this nylon strap hooked to the hoist here, so I'm hoping if my adapter that I made down inside here blasts apart, this will at least catch that ram and prevent it from just completely shooting off into oblivion. So I am also going to wrap this with some heavy denim. I'm going to wrap the ram with a like an old t-shirt rag just in case it goes flying. Hopefully it's not just going to bash on the concrete. And yeah, hopefully we have some success. Scatter shield right here, and I'll be around the corner at the hand pump right down there. Kind of hiding, but we're dealing with homebrew stuff here, so anything might happen. Hopefully we pop it loose. We're doing it just as the book says, push on the bearing to push on the gear. Maybe we're going to blast the cover apart. I don't know. Let's give it a shot. $10 tons. Well, something went. That was about 22. yeah, I was just getting ready to call out 20 ton at the end of that last stroke. It popped up to about 22, and then that's when I heard it ting. So that was actually a little lighter than I was anticipating. Let's see if we can work this off. Yeah, lots of nasty black stuff back there. Grimy. There's our bearing. Okay. Okay. Let's get our first look at the adapter. Looks to be fully intact yet. Yep. Did the job. Let's try it again. All right, set up for round two. This is the one I haven't harassed yet. The one we just popped a minute ago, I had put the heat on and had in the 20-ton press and been hammering and everything. I haven't messed with this one at all, as you can tell by all the nasty black stuff that's still running out of it. So got the old GoPro set up, try and get a shot of the safety nut there. That's the sacrificial lamb at this point. If something explodes, well, I just hope I can get footage off it right. So we'll try and do a better job at calling out the tonnage on this one this time. We're moving the bearing at about 2 tons. 10 tons. 15. 20. 22 for the last one, Pop. 25. 25. All right, so, you wouldn't have thought it, but just taking and getting those bowl gears out of those covers has brought that old nasty grease smell right back to the shop. I did go last weekend and clean the final housings. They used to be just as nasty, crimey black as those, but they actually cleaned up pretty well. So the air was getting, breathable in here again, and now we went and did that. But I'll tell you what, I'm loving this setup right here. We at least proofed our adapter to 25 tons anyway. Doesn't look like anything gave up on it at all. So yeah, oh man, I'm liking this 30-ton ram. It helps to have, the base and the attachment plate and the forcing screw and just all the stuff that's meant to go right with it. And yeah, the old cylinder liner did the job again. This is how I adapted it to push on those bearings. I have this old bearing race, and I got a can with some stuff beneath the little press back there just for, pressing objects, pressing tools. This was in there, and yeah, it went and surrounded the shoulder on the shaft, and it pressed on the inner race of that sprocket bearing perfectly. So that's how we adapted the liner to work, and it all went very well. So yeah, here you can see, you have to unseat the bearing off of that shoulder, by probably 1/4 of an inch until it comes and bears up against the hub of the gear. So I'll end up pressing these the rest of the way off. I'm still not so convinced that they didn't suffer some damage from being mashed in like they were, but we'll clean everything up, really assess. But maybe now you can see how until you get the bowl gear off, the shaft isn't going to come out because the taper of the bearing locks it from coming out the back, so the shaft can only go out the front. The bearing can't come off the shaft because it's up against this shoulder on the front, and you know, the bowl gear being on the back of the cover just traps the whole thing together. So if you get the bowl gear off, everything else just flies right apart. So another interesting thing, these are the first generation straight tapered and keyed axles, or I should say sprocket shafts and bowl gears, correct for this early serial number tractor. About 2/3 of the way through the J Series production run, they changed to a splined taper on the bowl gear and then corresponding on the, I was going to say axle again, on the sprocket shaft as well. So this is what you usually see on D2s right here. Vast majority that I've been into have all had the splined taper because these straight tapered keyed ones did tend to loosen up even at, well, the 25-ton press fit that we had. But you consider they need to have them really tight on that taper because you've got all the gearing in the transmission, and then you're geared down again through the bevel gear, and you're geared down again, sorry, don't mess up now, through that pinion into the bowl gear. So these are the last leg of the system. They're going to have to cope with a lot. So we definitely have a lot of cleanup to do right here, but I'll tell you what, thinking that was well, I'm calling that a victory today. It was a lot of work making that adapter and kind of anticlimactic. I've heard them let loose with a bigger bang before, but you can see how they move so fast up against that safety nut once the taper finally releases that, you know, you don't want to have that very far off the hub at all because you don't want that thing picking up, you know, any more speed than is necessary because it just goes and slams even harder when it does come apart. But the way they move so fast, if you didn't have a safety nut on there, they'd probably fly a considerable ways. So it's just best to keep all that stuff locked together. But all right, that's enough for one day. Not pressing my luck any further. I'm going to bed in a good mood tonight. So thanks for watching, everybody. As always, membership's available down below, behind the scenes, additional ad-free content, all that. You know the deal by now. Thanks for the subs. Thanks for the watch minutes. Thanks for the views. Thanks for everything, everybody. Please tune in again.